Section 8.5 is going to discuss the properties of logarithms. So let's just go ahead and jump into it first. The product property says that if you have a logarithm of any base and it has a multiplication problem inside of it, you could break that multiplication up into saying it's the logarithm of the first number plus the logarithm of the second number. So there's a lot of similarities in these properties of logarithms to properties of exponents. So the quotient property says if you have a logarithm of any base and you have a division problem inside of it, you could break it up into the logarithm of the numerator minus the logarithm of the denominator. And then the most important property of logarithms, in my opinion, is the power property, and it says that if you have a logarithm of any base that has a variable or a number raised to an exponent, that exponent really belongs down in front of the logarithm, and that's where they write it. And that's really, in my opinion, the purposes of logarithms. So let's look at number 5. Log base 2 of 4 to the 5th power. This, and the way I'm looking at it, is the power property, which says this power really belongs down in front. Now I want to try to do this without our calculator. So it's really 5 times the log base 2 of 4. Now think about evaluating log base 2 of 4. That's saying 2 to what power gives you a 4? Well, what is 2 to what power would give you a 4? And we can see that the answer is 2. So this is really a 5 times 2, which of course is a 10. So here I see a division problem, which means it's the quotient property. So log base 3 of 1 minus log base 3 of 3. It has to go numerator first and then denominator. So again, I want to use our brains, not our calculators on this one, because it is faster. 3 to what power would give you a 1? And if you think about that, 3 to the 0 power would give you a 1. And then 3 to what power would give you a 3? And 3 to the first power would give you a 3. So 0 minus 1 gives us a negative 1. Now some of you saw right away that 3 to the negative 1 power gives us a 1/3. And that would have been another way to do that question. I just wanted to show you the property of the quotient property. So number 7 is a product property. So we're going to break this up into the log of the first number, 3, plus the log of the second number. So again, use your brain. 3 to what power gives you a 3? And that would be a 1. And then for the second part, 3 to what power gives you a 9? And that would be a 2. 1 plus 2. Our answer for this problem is 3. Now on number 8, it's just log base 4 of 64. So just to show some property, I need you to rewrite 64 that it's something else. So whether it's a multiplication, a quotient, or a power, I don't really care. Just for fun, I'm going to write 64 as 4 to the 3rd power, because that is 64. And I'm going to use the power property, which says this power comes down in front. So now we've got 3 times log base 4 of 4, and actually, now that I realize it, I could have used an inverse property, but that's okay. Log to the log base 4 of 4, whoops, is asking us 4 to what power gives us a 4, and we know that's a 1, so this is really 3 times 1, which is a 3. Again, right here I could have said log to this log base 4 of 4 cancels. Okay, so now we're going to use algebraic problems, so we're not going to have the ability to use our calculator, so you really have to understand the property. So the first thing I notice in number 9 is that I've got a multiplication problem right here, I've got a power problem, and I've also got a quotient or a division problem. So I'm going to use all 3 properties. The trouble is, though, is you have to realize which one to use first. And the power, or the property that is involving all of the numbers, the 7, the x, and the y, is the division problem. So I'm going to start by breaking this into log base 2 of 7x to the 3rd, that's the numerator, minus log base 2 of y. Now notice the base 2 is just the type of logarithm, it's just the name of the logarithm, and you don't do anything with that. Now this back half is all simplified as much as it can go, but this first part, I see right now a multiplication problem that I need to break apart. So this becomes log base 2 of 7 plus log base 2 of x to the 3rd minus log base 2 of y is still there. And we're almost done. The first logarithm, all broken apart, we're good. The second logarithm has this exponent, and remember the power property says bring him down in front. So your final answer is log base 2 of 7 plus 3 log base 2 of x minus log base 2 of y. And that is the answer I'm looking for. Now, it's kind of hard at first to realize if you're done. You know you're done with an expanding problem if every logarithm only has one thing inside of it and there are no more exponents. They've all been brought down. These will get easier with practice. Okay, number 10. We've got log of 7/9 raised to the second power. Now you could do this a couple different ways. You could distribute the 2, you could bring the 2 down in front right away. I'm actually going to go ahead and distribute the 2. And I'm not going to simplify. So we've got log of 7 squared over 9 squared. And now I'm going to break apart the division problem. So remember, division breaks into subtraction. So it's the log of 7 squared minus the log of 9 squared. And then the only thing I have left to do is to take this exponent and put them down in front of their logarithms. So we have 2 log of 7 minus 2 log of 9. Now, if you chose to bring the exponent down in front at the beginning and wrote it like this, that's fine, except when you break apart the division problem, you would have to remember that this 2 coefficient is going to go to both of the logarithms. So you'd have to remember to use parentheses and then distribute the 2. Either way, you're going to end up with the same answer, but you just got to be careful about the distributing of the 2. Okay, number 11. Let's look inside of the logarithm and see what we have. I see a multiplication problem, another multiplication problem, and then a power problem, but it's only on the x. So I think the first thing I'm going to do is break this logarithm apart into its additions. So we've got log base 3 of 2 plus log base 3 of x squared. And some of you already know what to do to simplify that, and that's fine. Log base 3 of y. Now the rest of us are finally caught up to you, and we realize that we're supposed to take this exponent and put it down in front. So our final answer is log base 3 of 2 plus 2 log base 3 of x plus log base 3 of y. Our next problem is going to have us condense. So we're going to go the other order. So we're going to take our logarithms and put them back into one logarithm. So we're going to go in the backwards of what we just did. We're going to take all of our, what used to be exponents, and put them back. So right here, this 2 is going to be put back up into the exponent position. Log of 6 plus log of, now that's 2 squared, minus log of 3. Now I'm going to change this 2 squared to say 4. Now we work left to right, just like we would read. So we're going to start here. If I add 2 logarithms together, the product property says to multiply them. So if I write them as a single logarithm, it'd be 6 times 4, which is 24. And we still have minus log of 3. And then if I bring together a subtraction problem, the quotient property says we're supposed to divide that when we write it as a single logarithm. So instead of 24 over 3, we want to simplify as much as we can and say this is really the log of 8. So I think condensing is a little easier. Okay, same thing here. We first look for any exponents, and it turns out there are no exponents that need to go back up. They're already kind of halfway together. So the addition of 2 logarithms, when I bring them together into one logarithm, log base 8, we are supposed to multiply the inside stuff. So if I multiplied 5x squared times 3, I get 15x squared. Here in the next problem, I see that this exponent needs to go back up, and this exponent needs to go back up. So we've got the log base 4 of x to the third minus log base 4 of y squared. And then the quotient property says if you're bringing together 2 logarithms that are being subtracted, we're supposed to divide their inside stuff. So it's still a log base 4, but I'm going to write it as a division problem now. So x to the third in the numerator over y squared in the denominator. When you're condensing, you know you're done if you only have 1 logarithm left. Okay, this is the best formula you'll ever learn. It's called the change of base formula. And our calculator can only do common logarithms and natural logarithms. So if I want to find the answer to anything else, I'm going to have to change its base so that my calculator can do it. So what we do is we take a logarithm of some other base and we turn it into a division problem of a common log over a common log or a division problem of a natural log over a natural log. So you can either type it in like this or like this. But notice the order is really important. The first thing you're going to have to type in is the log of the number, and then you're going to divide it by the log of the base. So I'm going to write that out right here. Log of the number divided by log of the base. So when I want to type number 15 in my calculator, I can't just type log of 7 because it's not the right type of logarithm. This is a base 3. So we can type in the common log of 7, make sure you close your parenthesis, divided by the common log of 3. Log of the number divided by log of the base. So let's pull up our calculator. Oops. So log of 7, make sure you close your parenthesis to stop that first logarithm, divided by log of the base, which is 3. It doesn't matter if you close that last parenthesis, but it's a good habit. So ugly answer, 1.77. And generally when I make you do change of base, it's because you can't do it easily in your head. So number 16, again, it's a base 2, something I can't do on my calculator. So you can do log of the number divided by log of the base. Now just for some variety this time, I'm going to use a natural logarithm because that's another way I could do this. So natural log of 147 divided by the natural log of 2. And if you chose to use common logarithm, you're still going to get the same answer because they're in the same ratio. Natural log of 147, close parenthesis, divided by natural log of 2, and you get 7.2. And then 17 you can do with whatever common or natural logarithm. So I'm going to do common this time. Log of 50 divided by log of 6. So yes, you need a calculator to do these. If for some reason you're doing your homework and you don't have a calculator, just draw what you would have typed in your calculator out, and then hopefully you have enough time when you come back to school to type them in. So 2.2. Oh, I didn't round enough to the right places. Sorry. I should have read directions that said to round to the nearest thousand. Sorry about that. Should have had 3 decimal places. But anyways, that's our lesson on 8.5.